Well, hi everyone, this is Bob the Science Guy, and today we're going to talk about radiometric dating and how you do it on a slide rule and why it's so much easier to do it on a slide rule than it is to do it on a calculator. First thing that we need to do is we need to review the equation for radiometric dating. Now, if you take Euler's number E and raise it to the power of negative CT, with C being a constant and T being the amount of time, that'll tell you the remaining portion of carbon-14 in your sample of charcoal, for example. And then to determine the constant C, what we did was we took the half-life of carbon-14, 5,730 years, put that in as time, and set the amount of radioactive isotope left to be 1/2 or 50%. And then we calculated the value of C from it, and it turned out to be 1.21 times 10 to the negative 4. However, there's a much easier way of doing it. You recall on the slide rule we have things called table functions. So if we set something once on the slide rule, we can read it off like a table. Now up here on LL02, there is 0.5, which is 50%. We're going to go ahead and put the hairline directly over that, and then underneath it, we're going to move the slide on C 5.73. which is about right there. Now on some slide rules, there's actually a little r right there because that coincidentally happens to be the same value for radians, 57.3. That's a good way to remember it. That means that if we have 50% of our sample left, 5,730 years would have elapsed. Well, what if we have 25% of that sample? Now, if we come down here to 25, we find that it's actually on LL3. Now there's an interesting thing that happens when you increase the scale number. So if you go from LL1 to LL2, you have to multiply your results by 10. If you go from LL2 to LL3, you have to multiply your results by another 10. And that's because as you look at the legend over here, LL1 is 1/100th of X, whereas LL02 is 1/10 X, and LL03 is X. So if we're at 25% under the hairline and we read straight down to the C scale, we see 114, and that is 1.14. Now we were dealing with thousands of years on LL02, so we're dealing in 10,000 years on LL03. So that's 11,400 years, which kind of passes the smell test, because if a half-life is 5,730 years and you've gone through 2 half-lives, that's 11,460 years. So that gave us a pretty good result. So 0025 equals 11,400 years. What if we have 10% of our sample left? So that would be 0.10. How many years would that be? Well, once again, we would come down to the LL3 scale and come out to 10%. Which is right there. And without moving the slide, we read 1.9. But again, we're dealing with 10,000 year increments here. So that would be 19,000 years old. Likewise, if we have 1% of our carbon-14 left, we would come out here. There's 0.02, 0.015. This is 0.01, or 1%. Let's read down and see what we have here. It looks like almost exactly 38,000 years. So once again, all you need to do is come out here to 50%, which is 0.5, put the half-life of the substance underneath it, in that case 5,730 years. What about this big equation up here? So let's go through the equation real quick and see where this came from. So E to the minus C, and then we're going to put in 5,730 years, equals 0.5. Now, I did the math last time. You can do it again now if you wish. If not, you can take my word for it. Trust me, bro, math. Now, if you want to figure this out for 10% left, for example, what you end up with is negative 1.21 times 10 to the 4th times X time equals the negative natural log of 10. Because remember, where did this come from? This came from 1/10th. We took the natural log of both, the natural log of 1 minus the natural log of 10. Natural log of 1 is 0, so we had negative natural log of 10. That's where we got it from. So finally, what you end up with is X in years equals negative natural log of 10 over negative 1.21 times 10 to the negative fourth. And if you do the math for that, you'll see it comes out to roughly 19,000 years. But that's what you have to go through to do it on a calculator, where on a slide rule, you just read the table right off. What about this 1.21 times 10 to the negative fourth? Where's that? Remember, all we had to do is we had to just put the 0.5 on LL2 directly over the half-life of carbon-14, which is 5,730 years. Well, where did we end up over here? There's the 1.21 right there. We already set that up when we set up the original proportion. You know, it just kind of fell out of the slide rule right there. So now it's time for you to have some fun. Get yourself a calculator, a scientific calculator that can do natural logs, and calculate some ages for carbon-14 artifacts. You know, do 35% remaining carbon-14. Figure out how many years that is. Do it on the calculator and then compare your results to the slide rule. See how they look. And I think that you'll find the slide rule is a lot easier to do. So, this is Bob the Science Guy. Next time we'll talk about everybody's favorite thing, compound interest. Take care, guys.